Good morning from Strive Academy, and here's your host, Emily.
Isn't that a fun introduction? Welcome back to Friday morning at Strive with our virtual STEAM activities. We've been having so much fun, and this is now the end of week 3, so this is our 15th experiment or activity that we've done. We hope that you're following along with us at home. We hope that you're at least doing some of them, whichever ones you're interested in. But don't forget that you can go to our website at www.striveacademy.org and you can see any of our past experiments. So just click on virtual STEAM activities and you can look at any of our experiments. You can look at the videos. So definitely if you've missed some, feel free to check them out. You can watch the videos. I have 3 helpers today and they're really excited because we are going to be blowing stuff up.
Yay!
Well, kind of. We're going to be blowing up a balloon. Normally, we blow up a balloon by putting carbon dioxide into it. So when we blow into it, we are breathing carbon dioxide out of our body. We take in oxygen. We let out carbon dioxide. Today, we're going to try to blow up a balloon by creating carbon dioxide from a chemical reaction, not from our body. So the title of our experiment today on your Strive paper that you can print from our website is called Balloon Blow Up. So go ahead and fill that in. Balloon Blow Up. Bailey, can you copy it from right up here into the box?
Just right here. Balloon Blow Up.
Or right, however much you can. Or you don't have to, babe. Okay, and our goal today, again, is to see how we can blow up a balloon without actually blowing into it. So how can we create carbon dioxide to blow up the balloon from a chemical reaction? And we're going to do that today by adding baking soda and vinegar. And to test this out, we're going to be adding different amounts of baking soda and vinegar. And so the hypothesis that you're going to answer today, the question that we're investigating is, does the size of the balloon change if you change the amount of baking soda and vinegar? So what that means is if we add a little bit of baking soda and vinegar or a lot of baking soda and vinegar, will that change how big your balloon blows up? So go ahead and fill in your hypothesis. Tell us what you think is going to happen.
I think...
Bailey, you can just put yes or no. Do you think the amount of chemicals that we put in are going to change how big the balloon blows up?
I think yes, because the more carbon dioxide that you put into a balloon, the bigger the balloon.
Okay.
So that is going to form carbon dioxide.
Okay.
Yes, because the more the bigger.
Okay. Why? Why? E. S. Okay, so I think all 3 girls are in agreement that the more baking soda and vinegar we put in, the more carbon dioxide we will make, and therefore the bigger the balloon will get. So we'll see what happens. Just put CO2. Okay, so number 3 says draw a picture of your design. So I want you guys to draw a water bottle.
1 second.
And then draw a sketch of what you think it will look like when the balloon gets blown up.
Wait,
so remember,
we're gonna pour it into here, then we're gonna put the balloon on there, then we're gonna go like this.
Nope, we're gonna leave it like this, and we're gonna put the balloon on like this, and we're gonna dump the baking soda in and blow the balloon up.
Yeah, but how's baking soda going to go in?
We're gonna dump it in. So draw a picture of what you think. Ooh, Bailey, let's see your picture. That's really good. Good.
How big the balloon?
Yeah, that's big. Okay.
This is mine.
Okay. So I want to talk about the data collection and observations and also the results before we get started. Because when we wrote the directions for this, there's kind of a lot of things happening at once. So if you wait to read the directions until you've done all of the steps, you might miss something. So it'd be really helpful to read through the directions first. As we do the experiment, in the data collection and observations box, we're going to draw a picture of what it actually looks like when the balloon gets blown up. And we're going to compare it to our original picture and what did it look like. In the results, we're going to record the amount of baking soda and vinegar that we put in for each trial and then how big the balloon got. So if you read through the directions, it recommends in the results section, go ahead and draw a table with one column being the amount of baking soda, one column being the amount of vinegar, and one column being how big the balloon blows up. I didn't give you guys this.
Can I see number?
Yeah, you guys can share that one.
No, I'm just gonna write on that.
Oh, okay.
Same.
Okay, the other piece of this is we need a way to measure how big the balloon is. So we can just look at it as it gets blown up and we can tell if it's bigger or smaller.
Put 3 columns.
Hang on. Yeah, baking soda, vinegar, size. So you could just eyeball how big the balloon gets, but of course, as a scientist, we want to get the best data that we can. So what we really need to measure is like a flexible tape measure. Well, I have those at school and I have those at Strive, but I didn't have any at home, like the tape measures that a tailor would use. So this is a suggestion for how you can do it. You can just cut like a piece of yarn or string or ribbon. And what we're gonna do is as the balloon blows up, we're gonna start at one end of the string and we're gonna measure around, and wherever my finger stops, then I'm gonna hold that up to a ruler or a tape measure and I can measure how big the balloon got. So that's an easy way to do it. Okay, so what we're gonna do is in each trial, we're gonna add more baking soda and vinegar. We're just gonna walk you through the first trial and then you can see what happens when you add more. So the first thing we're gonna do is add a teaspoon of vinegar to the water bottle. Oh. Well, Harper. Okay. Can't move it. All right, I'll do this. So might be good to help.
I might
with
need
this.
a little bit more because.
That's okay.
Please. Oh.
Okay, and yes, vinegar sticks.
Wait, that's good.
So the next thing we want to do is put a teaspoon of baking soda into the balloon. Now this is the tricky part. If you have a funnel, you might want to use a funnel. Of course, I couldn't find. We looked. We couldn't find it when you were outside. So what we're gonna do is kind of. It's okay. I got it. We're gonna kind of stretch the balloon as wide as we can, and dump a teaspoon of baking soda in there. Okay. Now to make this a little bit easier, I got a half a teaspoon because it's smaller, and we're just gonna do 2. So 2 scoops. So if you guys want to hold it open as wide. Here.
Wait, really blow it up and then hold it open. It'll look better. See? How about you hold it up and then I pour it in?
Okay, now do one more. There you go. Okay, I'll help you guys with yours in just a moment, okay? And then what we're gonna do is we're gonna take the balloon. I'm gonna take Dylan's because she had a whole thing. And we're gonna put it on the water bottle, but we're not gonna dump the baking soda in yet. Okay, now you kind of need 2 people for this part. One person is gonna lift the balloon up and dump the baking soda in. One person is going to take the string or yarn or whatever you're using and measure around the circumference of the balloon. Now, remember, we have a chemical reaction going on, so pay attention to what happens when the baking soda and vinegar mix. So hold this down with one hand. Okay, and then go ahead and pull the balloon up, dump it in, let it go.
Cool. That tiny.
Okay, so it's pretty small. So what I would do is say, okay, it's this long, and I would get my ruler or tape measure, and I would measure the length, girls, and record it on my paper. Okay, now the next trial, you might want to add 2 teaspoons of baking soda and 2 teaspoons of vinegar, and then maybe 3 and 4 and 5, and see how big your balloon can get. We don't want to add too much because we don't want to pop it. But that's kind of the gist of the experiment today. When you're finished with it, You're going to look at your analysis questions. So did the amount of vinegar and baking soda affect the size of the balloon, and how did it do that? It says this is an example of an acid-base reaction which creates a gas called carbon dioxide. Where does the carbon dioxide gas go when it's formed? So where did it go?
In the middle.
Vinegar and baking soda have chemical potential energy. Does the amount of energy increase or decrease as you add more vinegar and baking soda, and how do you know? And then you can always try our extension activities. So for example, you can swap the variables. So instead of changing the amount of baking soda and vinegar, you can change the size of the bottle. So maybe use a 1 liter or a 2 liter bottle based on whatever you have in the house. A really fun thing to do is to draw with a Sharpie some kind of fun design on the balloon, or you could spell out a word on the different balloons, and then when they blow up, you can see the word enlarged. The third extension I think is kind of fun. So the idea is to blow up one of your balloons using the carbon dioxide and vinegar, or sorry, the baking soda and vinegar, and tie it off, and then blow up a balloon using your carbon dioxide and your body, so using your breath, tie it off. Hold one balloon in each hand, let your arms stretch out, drop them at the same time, let them fall, and see how they fall different, because they will fall different based on what's inside of the balloon. Okay, so we hope that you enjoy this experiment. Be sure to post pictures and tag us at #STEAMWithStrive. And we will see you guys next week. Have a wonderful weekend. Do you guys want to say anything?
Bye.